Hi, hello everyone. Last time we left off, well, with this basic sprite, and this time we're going to deal with the rotation. And for that, it's going to be quite simple because we're going to actually use library, which we already have installed, GL matrix, and that's going to deal with our rotations. So we're probably going to need to fix that here and here as well in draw with sprite source. So let's just get to it and let's create this small variable which is just going to be called rotation. But before that, I'll just prepare this thing for testing. So we're going to use still draw with sprites, draw with source, but without this. And then I'm just going to move it a bit 100 by 100. So that's just so that I can test rotation. So let's get to it. So for rotation, we're going to have to change this a bit. So I'm going to do this now, and it's going to become clear really soon. Why? So it's going to be vec2, and it's from the GL matrix. So let's just create a couple of those. Then v1, v2, v3. And then I'm looking at draw with sprite source, but we're also going to have to do the same thing for draw. I'm actually going to do this somewhere over here. I'm just going to say this v0, 0. So it's basically an array. It's going to be this. And then we can just pass, instead of this doing this here, we can pass v0 here. You're going to see why, because I'm going to actually change this v0 depending on rotation, and here it must be v0 and then 0 index and then 1 for y. So then we can do this for v1 and both 0 and 1. So instead of doing this here, I'm just going to say this v1 0 and this dot v1 1. Then we're going to do it for v2 basically. All right, let's see exactly. So bottom right becomes v2 0, and it becomes v2 then 1. And for the last one, finally, and I'm constantly saving, just checking for errors. There are none. Oh wow, wrong. Not here. Actually, it's for the position. So this v3 1. So nothing is breaking, so that's good. And now to deal with rotation, I'm just going to say if rotation does not equal 0. So we don't need to rotate if there is no rotation. But here it just becomes, we can use vec2 dot rotate. And then we can rotate around by default. Sorry, I was just testing this stuff that I'm going to explain in a video. But by default, we're going to rotate around this point. So we can just pass here with 0. Then we're going to do this for each one of those. So the first parameter here, it just means that we're going to assign it to v0. Which one are we rotating? v0, around which point? Here v0, and here it's going to be 1 because we're assigning to v1. We're actually using v1 for rotation. Here, therefore, it's 2, 2, 3, 3. If I save it, nothing's happening because we haven't specified any rotation, but let's do that. And here in our engine, so how can we easily test rotation? Well, I'm just going to assign some global variable rotation. And here for our sprites, I'm just going to say rotation plus equal 0.01 maybe. And then I'm just going to pass it here. and that's actually argument for color. So we're going to say undefined and actually pass rotation a second. And yeah, as you can see, it's rotating around this point where I mentioned that it's going to rotate about. But what about rotating around center or around any of the other points? Well, it's actually really easy as well. So I'm going to specify one more variable, and I'm going to call it private rotation origin, and it's also weak 2. I'm using underscore because the parameter is going to be called rotation origin, so I don't want to confuse you with that. And we can just say here rotation origin is of type vec2, but by default it's undefined. Will this work? Maybe null. I must say or null, apparently. That's all right. So if we have our origin, so our rotation origin, by default we're going to use, so we're going to do this. We're not discussing this yet, so I'm just going to do rect x, this is 0, and then for 1 let's set y here, and I'm just going to use this rotation origin instead of v0. I guess it makes more sense. Nothing is broken, so that's good. And then if we have rotation origin, if there is this one here, we can just move this origin. And how do we move it? Well, we can say plus equals. So what are we adding here? Well, if you take a look at rectangle here, let's say that we're at let's say we have some rectangle and x is 100. So how do we get this this here? Well, we can just say plus width, but I want to use normalized coordinates between 0 and 1, right? So to represent this coordinate, it's going to be, for example, 1, 0 origin. Here it's going to be 1, 1. So I can just multiply this by origin.x. So this is origin.x, and I'm just going to do that. So we're going to use this width. So where do we get width for? Well, from the rectangle, right? Times rotation origin 0, and then we do the same for the height. So one here, and let's test it out now. So in our engine, we're just going to create const origin or rotation origin, and then we can use vec2 from values, and let's just say 1, 1. So sorry, 1, 0. So we're testing rotation about upper right corner, and then we can say origin. And as you can see, it's rotating around this corner. So if we wanted to rotate around center, we can just say 0.5, 0.5. And as you can see, it's now rotating around center. And well, that's basically it almost for this video. So I just need to do it for the other one, and then I'm going to explain rotation a bit. So just for all of those who want to have a bit more of this. So let's do that. Let's go to our sprite renderer. I'm going to be very lazy, and I'm just going to copy paste all of this to here. And then I can just specify our parameters as well. So it was rotation and origin. And then I just need to paste them here. So it was this v1, this v0, 1, this v0, sorry, wrong. This is 1, this is 0. Then similar here, I'm just going to paste from top right here because I'm lazy. So I can use I can use that here. Actually, it's also kind of slow because I have to find everything. So I just going to v2 0, then v2 1, v2 1, and then this v3 1. So let's test that method out as well. Somewhere in our main, no, sorry, the engine. So we had this overload, but let's just use draw overload, draw sprite, and it doesn't have source rectangle. So it's kind of same. I'm just going to move it a bit to 200, 200. And this one is also rotating around the origin. If I change it to 1, 1, so lower, so this corner, it's also rotating around that corner as well. So that's good. That's good, and generally that's how it works. So now I need to explain you a bit rotation. So this is for all of, actually let's do just one more thing before that. No need. Actually, let's just explain rotations. This rotation matrix, I'm just going to Google rotation matrix, then we can look at it here. And basically, well, this is rotation matrix. So the part that you want to pay attention is this. So this gets you the rotation matrix. And how does it work? Well, let's imagine, let's take a look at here, and let's do this small thing. I'm just going to hide this for a moment. It works all right. We already confirmed that. Not delete. What have I done? I'm just going to say return here, so that I don't have to delete this. Then I'm going to remove it later. But so let's say that we have some vector which is 10 in x direction, it's 0 in y for simplicity. So we want to rotate it around, well, basically, we want to rotate it, let's say 180 degrees. So once we're done with it, it's going to be minus 10, 0. So this rotation matrix defines just that. I'm not going to go into the math that much, but I'm just going to show you that it actually works. So we had this case, and let's bring our console now. So what did we have? Let's say we had we had x, which was at position 10. So once we're done with it, it needs to be at minus 10. So we can just set may dot cosine of may dot pi and pi. So we're going to, when you work with rotations, you need to use radians, right? So you can actually convert radians to degrees. Sorry, you will need, if you want to use degrees, you're going to need to convert them to radians. But for now, let's just use radians here. So that's math. You can already see you get minus 1, right? And then if you just multiply by x, you get minus 10. And here I'm just going to not use, I'm not going to use y here. So I now rect the y 0, but you can also check with this. You can add this. So if you want to add this, I can actually add it. So I can say let y 0. So that was our vector. So I can say math that cosine of, what was it? Math pi. It was time x, and then minus my dot sine what math pi and times y. Since our y is really 0, it's 10. But but let's see next problem. So let's imagine for a second that we have a vector that's at position 110 and 0, and we want to rotate it around vector 100 and 0. So our resulting vector is going to be 990, 0. So how do we rotate around some arbitrary point? Well, it's same it's really easy. You just need to correct x. So let's say our x is 110, and we have our origin x at 100. So how we do that? How do we do that? Well, we can just say my.cosine my.pi times. So basically, we need to we need to bring x to essentially space 0, 0. So how do we do that? Well, we take our x, we subtract the origin, right? It's minus 10. And then when we add the origin, it's actually at 19. So you kind of have to do this, right? First, uh, you subtract from the x the origin so that you go to 0, 0 space, right? So that our well basic rotation vectors becomes kind of 0, 0, and then you just add it back. So that's how you do it. And same is true for y. So if we had y vector as well, we could just say mat.sine mat.pi times y minus origin y plus origin y. So that would be if we had origin y. I haven't defined it, so that's why it fails. So that's how it works. If you wanna define rotation matrix yourself, you can do it. I'm just going to use it from the library. So that's basically it for this video. Hopefully you enjoyed it, explanation as well. And also one more thing, I actually created Discord channel where you can ask questions, any additional questions. We can also have discussions. So I'm going to leave it in the link of the video. If you enjoyed this video, like it, subscribe, and until next time.